Rationalize the denominator. Assume variables represent non-negative values. So we have the square root of 16 over 3. When I divide the 3 into the 16, it's not going to go in evenly. It's going to create a decimal. So I'm going to pull the square root out onto the denominator and the numerator individually. So I have the square root of 16 in the numerator over the square root of 3 in the denominator. The square root of 16 is a 4. So I'm left with the square root of 3 in the bottom. It told me, however, to rationalize the denominator. So I don't want to have a square root in the denominator's position. So to clear that square root, I'm going to multiply both the top and the bottom by the square root of 3. This will clear that radical sign out of the denominator's position. So when I multiply it, now I'm left with a 3 in the denominator's position, or in the bottom, and a 4 times the square root of 3 in the top. So now I've rationalized the denominator. I've removed my radical sign from the denominator's position. Number 17 says to rationalize the denominator, assume variables represent non-negative values. So again, I want to clear this square root out of the bottom of the denominator's position. So to start, I'm going to multiply both the top and the bottom by the square root of 5 minus 8. So what this is going to do is, when I use the FOIL method to combine the two together, or to combine them together, the square root of 5 times the square root of 5, or the square root of 5 times 5, will eventually go down to a 5. Then I have the square root of 5 times the 8, so a minus 8 times the square root of 5. Then a positive 8 times the square root of 5, so 8 times the square root of 5. And then the 8 times the 8 to make a 64. I'm also going to do the same in the top, so I have the square root of a 2 times the square root of 5, which is going to make a 2 times a 5. And then the square root of 2 to the 8, so I get a minus 8 square root of 2. Let's simplify this thing down. So these middle two terms cancel one another out, so they're gone. They're going to cancel out here in just a moment. But first I have the 5 times the 5 makes the square root of 25. So in the next step, square root of 25 makes a 5. These two cancel out. I'm left with minus 64. In the top, that 2 times 5 makes that square root of 10, minus the 8 to the second power. So copy that down. Now I'm going to take care of this 5 minus 64. So I end up with a negative 59. So I have a square root of 10 minus 8 times the square root of 2 over a negative 59. I can stop here because I've met with the instructions required. It said to rationalize the denominator. So the square roots have been removed from the denominator's position. So I can stop. On question number 8, it says, write the imaginary number using I. So when I pull this apart, I have, under the radical sign, a negative 1 times a positive 207. So I can pull them apart. The square root of a negative 1 times the square root of a 207. The square root of a negative 1 is an imaginary number, which we represent with the I. On the other side, the 207, I can break that down to prime numbers. So I end up with a 3 times a 3 times a 23. So I have a pair of 3s, so I can pull a 3 outside, and I'm left with the 23 under the radical sign. So pulling it back together, I have a 3 times an I for a 3i times the square root of 23 for my final answer. On question number 19, it says simply to multiply. So I'll use the FOIL method here. So I'll take a 5 times a 9 to get a 45, a 5 times a 4i to get a 20i, a negative 7i times a 9 to get a negative 63i, and then a negative 7i times a positive 4i to get a negative 28i squared. Now I'm going to pull together the like terms. So I have the 20i and a 63i. This makes a negative 43i to the center. an I squared, or an imaginary number squared, is the same as a negative 1. So I'm going to replace that with a negative 1 and simplify it. So now I have a 45 minus a 43i plus a 28. The 45 and the 28 are like terms, so I'm going to combine them to make a 73 minus a 43i for my final answer.